So what are the different types of hearing loss? And we like to break hearing loss into sensory neural and conductive. So if you look at the normal ear anatomy, and this is a left ear, you can see the ear here, and sound comes through the ear canal, it strikes the eardrum. That eardrum then vibrates these three bones, the malleus, the incus, and the stapes, or the hammer, anvil, and stirrup we learned about in biology class. The stapes is a piston bone that moves in and out of the inner ear and creates a fluid wave in the cochlea. And the cochlea is called the cochlea because it looks like a snail shell. Inside that snail shell or cochlea is a lineup of nerve endings called hair cells, which attach to a nerve behind the cochlea and go all the way to the brain and tells you that you're hearing. So if you were to draw a line right here at the stapes and go out, that's conductive hearing loss. If you look at hearing loss related to the cochlea or to the auditory nerve, that is sensory neural hearing loss. And there is a misnomer about nerve deafness. Nerve deafness is exceedingly rare, and that's typically if you don't have a nerve or the nerve has been damaged by surgery or radiation. The majority of nerve hearing loss or sensory nerve hearing loss is actually at the level of the cochlea, where those hair cells are damaged. They can be damaged by noise, they can be damaged by medications, and they can be genetically damaged over time just by your gene code. So if we were to break the treatments for hearing loss on the conductive side, oftentimes you'll see a hole in your eardrum or a tympanic membrane perforation if you go on Dr. Google. And we can repair those holes in your eardrum, but oftentimes they're accompanied with either stiffness or fixation of the ear bones, or those ear bones erode. Most typically, that's from infection. We can actually replace those. When we get on the middle of the ear from the cochlea to the cochlea, that's where we get sensory neural hearing loss. This is where we employ hearing aids, hearing devices that can actually stimulate a normal conductive hearing pattern or hearing pathway to get sound of the cochlea more effectively and boost it so we can take advantage of the remaining hair cells and nerve function.